Welcome and hi. My name is Muhammad Aziz bin Ramli. I am a Faculty of Engineering Technology student from the University of Northern on Malaysia. In this video, I'm going to present my final year project, which is the study of physical property of Hydrogel hydrogel and composite for the nerve bonded potential. Before we start, I'm going to brief a bit the background of the studies. Neuropathies is the most severe category for the peripheral nerve injuries. This kind of injury can lead to the disability and also a decline of quality life. The conventional treatment to treat this injury it is autograft and allograft treatments. This treatment offers many disadvantages, such as it cannot fully regenerate the damaged tissue. So the best alternative treatment is tissue engineering material. Tissue engineering material can treat the injuries by placing the biopolymer structure, which known as a scaffold, on the damaged site over time. This scaffold will provide a physical guidance for the cell to grow, and then over time it will degrade and replaced by the cell and grow to the healthy new cell. Currently, nerve currently the nerve scaffold available in the market is single hollow tube. However, this single hollow tube offer many drawbacks, such as low tensile strength, and then lack of physical guidance, and also not suitable for the large bridging gaps. So the best for my proposal, my final project is I propose by using the concept of Bilayer composite, which is by compositing hydrogel onto the single layer of Electrospun in order to enhance every characterization. So the objective of my study is to develop a Bilayer artificial tissue scaffold using electrospinning and coating methods. And second, to characterize the morphology and the mechanical property of Bilayer artificial tissue scaffold. So this figure is an overview how to fabricate the Bilayer composite scaffold. As you can see, the first step is of course fabricating the Electrospun nanofiber mat by using the electrospinning methods. My parameter is for the flow rate is 1 mil per hour, voltage of 12.5 kV, gauge needle size is 0.7 mm, and then the tip to connector distance is 20 cm. After the process done, the nanofiber was removed from the collector and then placed on the mold. At the same time, PVA collagen hydrogel solution was prepared and then it will pour on top of the nanofiber. Then the solution was treated with the freeze thawing treatment, where the freezing at negative 23 Celsius while thawing at 23 Celsius for 24 hours. And then this how the biocomposite will look like after the process done. And then this product sample will be tested with three types of tests, which is the swelling, water contact angle, and AFM. So let's see the results. Okay, the first result is a swelling degree test. So why do we need to study the swelling degree of scaffold? This to the swelling degree of scaffold contribute to the cell attachments on the scaffold. As we, for your information, as the scaffold swells, the size of the pore will increase, which directly increase the internal surface of the area attachment, while at the same time assisting the cell to penetrate easily into the scaffold and induce the three-dimensional of the cell growth. So at the same time, swelling degree of scaffold also determine the volume absorption of the body fluids with into the scaffold. Okay, back to the graph. As you can see, the nanofibers possess the poorest swelling degree compared to the rest of nanofiber. This due to the structure of the nanofiber, where the size of the interfiber pore of the nanofiber is so small until it reduces the potential of the water to penetrate within the scaffold. So as we look the result for the Bilayer scaffold, it shows the highest degree swelling compared to the rest of the type scaffold, hydrogel and nanofiber. So the reason is by compositing the both type of element, of course the swelling degree will be increased, especially when there's a presence of the hydrogel. Hydrogel possess high degree of swelling due to it contains large density of hydrophilic crossing in the structure, where it can greatly increase the polymer water interaction. This suggests that by composite structure scaffold have performed much better compared to the single scaffold. Okay, let's see the FM image, which is the morphological structure of the scaffold. So this test FM is an ideal test to analysis and observe the surface morphological structure and also the roughness of the sample in the nanoscale value. As you can see, all the type of the samples in the nanoscale roughness, which means it offers a good self-polarification and also attachment. AB is represent for the nanofiber. CD hydrogel. EF is the hydrogel of the bioscaffold. GH is the Electrospun nanofiber of the bioscaffold. As you can see, as we compare result from the single layer and also biocomposite scaffold, the biocomposite scaffold offer much smoother structures compared to the single layer. As you can see, the nanofiber literally is improved significantly from the 192 to the 5 nanometer. So the reason is because hydrogel, as a hydrogel composite to the nanofiber, the hydrogel fill up the most interfiber pores and also hollow in the nanofiber structure. Therefore, the nanofiber has much smoother morphological structure. This suggests that by compositing hydrogen on nanofiber, the roughness of the scaffold improves significantly. As we see the water contact angle result image. So water contact test is a test where we can observe the wettability characteristic of the samples. So A is an Electrospun, B is a hydrogel, C is a nanofiber for the Bilayer, and D is a hydrogel of the Bilayer. As you can see, the nanofiber is the only sample that possesses a hydrophobic characteristic. The reason is because due to the roughness structure of the nanofiber, the water having a difficult times to penetrate into the interfibers and hollow of the nanofiber. Therefore, the water resting semi A and also semi fill of the scaffold. Therefore, the water contact value is high. As nanofiber composite to the hydrogel, its wettability increased significantly. So the reason is from the AFM result, where the hydrogel has been filled up the most hollows and interfiber pore, which is enhancing the surface smoothness of the scaffold. From that result, in conclusion, the incorporation of the hydrogel to the Electrospun nanofiber scaffold able to enhance significantly its physical properties via swelling, water contact angle, and also AFM micrograph. This suggests that Bilayer composite scaffold offer more robust advantages that thus it potentially able to regenerate and damage peripheral tissue than the conventional scaffold. For the suggestion, the characterization of Bilayer composite scaffold can be further studied with the FASTAM analysis to observe the morphology structure of the scaffold much more detailed. Next, FTL evaluation should be conducted at the wide range spectrum from the 900 to 4000 cm to assess further the comparative chemical structure within the scaffold. Thank you so much.